Okay, you guys, today we are starting at the middle of page 16, talking about the cosine wave. It says here, using graphing calculator, graph the function y equals cosine x. Let's pull out your graphing calculator and let's graph that and see what it looks like. So on my calculator, I'm going to keep the sine of x there just so we can see it. You can choose to or not to, I don't care which way you go on that. And then also enter, though, the cosine of x, and let's see what those look like. Remember, when we go to look at it, we want to go to Zoom Trig just to make sure that we are seeing what we want to see in the right spots. So here's my sine wave, and then this here is my cosine wave. For the sake of this, I took off my table because I just think it's a little bit more helpful today to see it without the table. But a few things. Notice how similar they are. They look almost exactly the same. They have, what are some similarities they have? Well, they have the same amplitude as each other, and they appear to have basically the same wavelength, the same period. The only difference is where they start. It's almost like one of them has been shifted over, and whether you call that shifted over to the left, or maybe you want to say, no, actually it was shifted over this way. But in any case, it has been shifted over. We know that the sine graph usually starts at 0, 0 and goes up. And the cosine graph, though, starts at the top of the wave and goes down. And so we've been talking about how much is a full period and how much is a partial period and so forth. So a period for the red one, the cosine, starts here and goes all the way over to here. And so we will draw that on our paper, but this is what it's going to look like as we graph it. It looks very similar to sine. It's just that it starts at the top rather than starting at the middle. Let's look at our paper. Okay, so the parent graph of y equals a cosine x starts at the top of the wave and goes down. And so I'm going to stick with my counting by 2 boxes. I just feel like that gives me some more space. The period is the same, so my period is still going to be 2 pi. And so to find my x-axis, I take that 2 pi and divide by 4, and I get pi over 2. So on my x-axis, I'm going to count by pi over 2's. Same thing in the negative direction. I'm just only labeling those just because I'm lazy. So we're going to start at the top of the wave and go down. So we're going to start up here at the top and then go down, down, up, up. But again, this is not a V, it is a curve. And so one period of the cosine curve looks a little bit like this. The period is still 2 pi. It just started at a different spot on the wave. And so again, we can continue this in the negative direction. And so when you have more than one period stuck together, it really looks a lot like the sine curve. It's just been shifted over because the sine curve started here basically and went up, down, down, up. Remember? So the sine curve kind of goes like this, but our cosine starts here instead and goes down. So they are very, very similar. All of those high-low rules that we had before, literally all I did was copy and paste those rules and I put them here. So the A is still the amplitude, the vertical stretch. The B is still the horizontal stretch. We find it by taking 2 pi over b. The phase shift is horizontal translation. That means that it goes left and right. That's what that is. And the vertical translation is the last number that's added on to the end, sending it to go up or down. Let's talk about similarities and differences. Similarities, we've talked about this a second ago. They have the same amplitude. They have the same period. They have the same transformation rules. Differences, the cosine starts at the top of the wave and goes down, whereas the sine starts in the middle of the wave and goes up. Other than that, those two waves look exactly the same. Now let's turn the page. Okay, on this example, I moved my axes over a little bit, and I have a little bit different graph paper, but that was just so that we can fit everything where we needed to fit. Because let's look at this and let's see what's going on. The period, we always take the period by finding 2 pi over b. In this case, our b is 1, and so our period is just 2 pi. So for our x-axis, we take that and we divide by 4, and it gives us pi over 2. So I can just graph. So I'm going to count by pi over 2's, and I'm going to get my x-axis set up from the period. That's how we always do it. The amplitude, let's look at the amplitude. The amplitude is 2. That means we have to be able to go up 2 or down 2. Now, we're a little off, but there's a reason for that. The reason is the vertical shift. We have a down 3 vertical shift. What that means is we usually have a center line going on the x-axis, but since we have a -3, everything is going to be shifted down 3. And so this center line is also shifted down 3. Now when we do our amplitude, up 2 and down 2. All right, phase shift, what's that? Phase shift comes from the middle, that plus pi. Remember, plus means left, so we're going to go left pi units. Okay, when I go to graph this, I'm going to pretend like I'm graphing the parent function, and then I'm going to move over and do my transformations. In other words, usually the parent function starts at 0, 1 at the top of the wave and goes down from there. This is different though. Number 1, we take it down 3. So 1, 2, 3. We're going to come down here. Another thing though, this is supposed to be at the top of the wave. Well, the top of the wave has an amplitude of 2. So I don't actually want it where I had it a second ago. I don't want that. It needs to be up here so it went down 3, but it needs to have an amplitude of 2. It's going to start there. That is the top of my wave. Oh, not even. I need to go left pi units. So now I need to take this and move over here. This is my starting point. Forget that. Forget that. This is my starting point. This is the top of the wave, and I'm going to go down. I have it broken up by the correct increments, so I just need to go down to the center. And then again, my amplitude is 2, so I'm going to go down 2, and then up 2, etc. So my graph looks like this. Let's analyze this again. Let's just make sure we understand what's going on. Remember, this was basically my starting point. That starting point, the original parent function says, let's start here at the top of the wave and go down. But this says we need to go down 3. So now we're down here. But this says it needs to have an amplitude of 2, so we want to come up here, so it's 2 units away. And then this says let's move over pi units. So this is my starting point. Up here at the top of the wave, and then I go down. 1 full period, if I wanted to graph 1 full period, that is 1 full period. It's kind of like a V with a little bit of a wave on the end. So that is 1 full period. And then the rest of it just falls into place after that. The center line helps us to find the middle. I didn't draw it, but we talked last time about drawing a highway line. So we could draw our highway line in here and here. And the reason I knew that is the center line was in the middle, and the amplitude is 2. So I went up 2, drew a line, down 2, drew a line. Let's take a look at another example. It keeps repeating this. Be sure to show the scale on both axes. So you really have to do that. Again, I've set these up a little bit for you, but we have to make sure we know what we're doing. All right, the period is 2 pi over b. In this case, it's 2 pi over 2, so that's pi. For our x-axis, we take our period and we divide it by 4. That's pi over 4. So I'm going to count by pi over 4s. So 1/4, 2/4, 3/4, 4/4, 5/4. And then going in the negative direction, negative pi over 4 is over here. All right, that's my period. That is my x-axis. The amplitude, it's 1. It is an absolute value. That is, the negative sign, it's just an absolute value. That's a -1, but the amplitude is just 1. Okay, the phase shift, that would be in here if we were adding or subtracting anything. We're not, so we don't have a phase shift. But the vertical shift we do have. We are going up 1 unit. Okay, vertical shift going up 1 unit means I'm going to draw my center of my highway here on 1 because it went up 1. The amplitude is 1. That means I can take the outside of my highway and draw it 1 unit away from the center. We're not going left or right anywhere. That's good. Let's talk about the parent function. Just a basic cosine function would start at the top of the wave and go down. However, what does this negative mean? It means we reflected across the x-axis. So we need to take our highway and flip our highway upside down. It looks the same. The highway looks the same when we flip it up and down. So we flip our highway up and down, but what that means is we need to take this starting point that usually starts at the top and goes down and flip it. So it's going to start at the bottom and go up. And so our graph is going to look like this. That period of just being pi should make it look more compressed. Ours does not look compressed because we spaced out our increments. Usually what we've been doing is calling this pi over 2, and then this is pi. So we've spaced things out a little bit more. And so when we did that, our graph looks a little bit more spaced out than maybe it would be if we had the same increments. But when I check it, when I check your graph, I'm looking to see, do they have their points in the right place? In other words, is the crest, the top of the graph, there at pi over 2, and then is the bottom of the graph, the trough, down here at pi? And it is. And so I've graphed this correctly. That negative is what threw us off by putting it upside down because a parent function, I'm going to just draw this so you can see it. A normal cosine graph would follow that dotted line, but we're not doing a normal cosine graph, we're doing a negative cosine graph. Okay, that is our last example because these are so similar to the sine graphs that there's not really a whole lot new information. And so we pretty much have all the information we need. So we're done with the notes for here.